Hello everyone, welcome back to this exciting video in chemistry lessons. Now in today's video, I will be talking about the calculations involved in the calculations of standard electrode potential of substances of a cell. Now in this particular video, we're not going to waste time, so we're going to be going deeper so that at the end of this video, you should be able to calculate questions on standard EMF or electromotive force of a reaction or of a cell. Now we continue. And the question says, calculate the standard EMF of a cell containing this, which is tin 2 ion and tin and bromine molecule and bromide electrode. These are their standard electrode what now? Potential. Standard electrode potential. So we'll not waste time. We'll do it. Question 1. Take note. The formula is the standard electrode potential of a cell is equal to the electrode potential of the cathode, right, minus the standard electrode potential of the what now? Anode. And remember that in the anode, reduction occurs in the where now? Reduction occurs in the cathode, while oxidation occurs in the what now? Anode. So it's actually very simple. So what do we do here? Look at it in such a case like this. Remember, if you are having positive and negative, here is the bromine here is taking positive, while here is taking negative. Take note, the one that is positive, right, will undergo reduction and it is known as the oxidizing agent, while the one that is negative will undergo oxidation and it is known as the what now? Reducing agent or reductant. So it's simple. So the formula here is actually very easy. It becomes 1.08 minus bracket minus 0.14, which is now equal to 1.08 plus 0.14. The final answer becomes what now? 1.22 volts. It's as easy as that. So this is positive. Now before we continue, we should understand when a reaction is feasible or not feasible. Now when a reaction is feasible, it simply means that that reaction can occur. And if that reaction can occur, it simply means it is a spontaneous process. Now take note. For a spontaneous reaction, right, the electrode potential of the cell should be or must be positive, while the free gift energy should be negative or less than 0. The opposite is the case of non-spontaneous reaction. So this answers our question 1. Look at the way it is solved. It is actually very easy. If one is positive, one is negative, the one that is positive is always undergoing reduction, right? So let us move to the next question as we calculate it. Very simple. Number 2. The question says, predict whether the reaction, this is the reaction here, is feasible or not. So we want to know whether it is feasible or not, meaning whether it can occur spontaneously or not. Very simple. So what do we do? Remember, they've already given you the reaction here. From 0 to +1 is oxidation. From +2 to 0 is reduction, right? So we apply the formula here, which is the E of the cell, this electrode potential of the cell is equal to, of course, the reduction minus the oxidation. Very simple. So we come here. The reduction here, right? The reduction here is what now? From +2, from +2 to 0, which is what now? Zinc. So it will be negative 0.763 minus bracket. The oxidation here, which is from 0 to +1, is what now? 0.80, which is now equal to negative 0.763 minus 0.80. The final answer becomes, let's do it together, minus 0.80. Final answer is negative 1.563 volts. Now, because the electrode potential of the cell is negative, this reaction is not feasible, and as such it cannot what occur. And this is the end of question under this part. Now follow me for my next calculation under this aspect still. Thank you and God bless you.